Hello everyone. In this video, we'll be solving problem 121, best time to buy and sell a stock. We are given an array prices where prices of I is the price of a given stock on the ith day. We need to return the maximum profit that we can make by buying a stock on a day and selling it on another day. We cannot make any profit, we need to return 0. In example number 1, based on the stock prices given to us, the maximum profit that we can make is if we purchase the stock on day 2 and sell it on day 5. That is, buy it for 1 and sell it for 6. The total profit will be 6 minus 1, that is 5. In example number 2, as the stock prices are decreasing every day, there is no way to make a profit, hence the output is 0. Let's switch to whiteboard and discuss a couple of approaches, starting with the brute force approach, following up with a more optimized one. In the brute force approach, we'll run nested iterations. The outer one will be to determine when we are buying the stock, and the inner one will be the one to determine the profit if we sell the stock on the particular day. If we start the outer loop with I pointing at 7, we'll run the inner loop on all of the elements after I to see if we sold the stock on those particular day, how much profit we can make. And if the profit is higher than the previously calculated profit, then we'll save it in a global variable which will be returned at the end. This way, we'll try all possible combinations to figure out the maximum profit that we can make by buying and selling the stock. The time complexity of this solution is going to be O of n square, as we are running two nested iterations on all of the elements in the input array, and the space complexity is going to be O of 1, as we are only using this one variable to determine the maximum profit that we can make. As the time complexity of this approach is exponentially high, let's discuss an optimized solution. If I try to break this problem down into smaller pieces, the first piece is to identify the minimum value of the stock that we should choose to purchase, and second is to sell at the highest point based on the price at which we have bought the stock. When we are looking at the lowest price at which we can buy the stock, we should always be looking at all of the values of the stock from the current day towards the past or to the left side. For example, if we are on day 3, the current stock price is 5. So we should determine by comparing the value of the current day's stock price to the previous days to say if we should buy the stock with price 5 or we should buy it for a different price that we have already seen in the past. As we go through the iteration, we'll be saving the minimum stock price in a variable which will be used to compare and calculate the profit. So in this case, if we start the iteration by I is equal to 1, the value is 7, which is minimum. But if we increment it to I is equal to 2, the stock price is 1, which is smaller. So it makes sense to purchase it for 1 instead of 7. We repeat this check every time we increment our pointer as we are iterating through the array. Now to figure out the sell highest price. This is going to be based on the difference of the stock price on the current day and the stock price that we have purchased in the past. For instance, let's say we bought a stock with price 7 on day 1. As we increment our pointer to the next value, the stock price on day 2 is 1. So the difference between the two is going to be negative 6. As the profit is less than 0, it doesn't make sense to sell it on day 2. So we continue to iterate and check for the next values in the array. At the same time, we are also updating the minimum buy price as we increment our pointer. So it is safe to say that minimum buy price will always be the lowest value on the left hand side of the index that we are at, and we want to compare it against the current index value so that we can make the maximum profit. If we let the iteration continue in this example, we'll be buying the stock on day 2 for price 1, and then at day 5, when the price is 6, we'll be able to make the maximum profit. Let's run a couple of simulations on this example to get a better idea. To start off, we'll buy the stock on day 0 so that we have something to compare the stock price against. So I will be 0, the price of the stock on day 0 or day 1 is 7, the buy will be 7 and profit will be 0 by default. Incrementing my pointer to 1, the price is 1. Between the previous minimum buy and the current stock price, it makes sense to buy it for 1 rather than 7. So we'll replace 7 by 1 in column number 3. And if we were to sell the stock on day 2, that is for value 1, and buy it for 7, the profit is going to be negative 6, which is less than 0. So we'll ignore it. For the next run, the I is 2, the stock price is 5. To calculate the minimum buy between 1 and 5, 1 is minimum, so we don't need to buy all the stock for price 5. So we'll keep 1 as is, and then we'll calculate the profit based on the difference between bought at 1 and sold at 5. As the difference is 4, which is greater than the previous profit 0, so we'll save it as a maximum profit so far. Similar operation for the next iteration where I is equals to 3, the stock price is 3. Comparing the stock prices for purchase, 1 is still smaller, so we'll continue with that. And the profit at this point is 2, which is less than the maximum profit, so we'll ignore that. For the next run, I is equals to 4, the value is 6. Comparing the buy price, it is still greater than the current minimum, so we'll ignore it. And then we'll calculate the maximum profit, which is the difference of 6 and 1. The profit is 5, which is greater than the max profit. We'll repeat the same iteration for remaining elements in the array, and at the end, return the profit as our output. With this solution, we have improved our time complexity to O of n, where n is the number of elements in the given array, as we are only running one iteration to figure out the maximum profit without having to run any nested iterations. The space complexity of this solution is O of 1, that is constant space, as we are only using these two variables to record the minimum buy and the maximum profit. I hope you were able to understand the explanation. Let me show you how we can implement this using Java. Here's the solution in Java. In the main method, I've initialized two variables. First is to record the total profit that we can make by doing the transaction, and the second one will hold the value for the best price to buy the stock. After that, I'm starting a for loop to iterate through all of the elements starting with I is equals to 1, that is the second element. Within the for loop, I'm first calculating the profit that we can make if we sold the stock on the ith day by comparing it with the best price to buy. If the difference between the two, that is the temporary profit, if it is greater than the previous profit that we have calculated, we'll save it into this profit variable using the math.max operation. After that, we need to check if there is a better price available to buy the stock. So using the math.min operation, I'm comparing the best price to buy with the current price of the stock at the ith position. And between the two, whichever is smaller will be saved back into this variable. After the for loop is complete, we'll return profit as our output. This code, when submitted on LeetCode, beats 75% of the submissions in terms of runtime and nearly 53% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.